here for number 4. This tells you that you have 25.5 grams sodium acetate solution of 0.550 acetic acid. So here, this is kind of a, do you remember the organic acid functional group, which is this? So that's the acid. And so this means this is the conjugate base. So here's the acid. So it wants to know what is the pH. Well, we're going to need to figure out the molarities before we can decide whether or not this is a buffer system. So we have a molarity here. We do not have a molarity here. So that's the first thing we need to do. We must be in molarity. So let's do that. 25.5 grams of NaCH3COO. Now, you got to use your periodic table. Come up with molar mass. Let's see what I remember. Sodium is 23. How many carbons do we have? 2. 2 times 12 plus 1.08 times 3 plus 2 times 16 for oxygen. 82.02. All right, so 82.02. Depending on how you round, it might be a little bit different. All right, grams per mole. Now, remember, molarity is moles per liter. Gotta remember that. That's a throwback to chapter 13. So, moles per liter. Well, we have 500 milliliters. So you can either do this conversion in your head, which is what I'm going to do. I'm going to say 0.5 liters, or you can convert it and say milliliters and convert to liters. You'll get the same answer. Okay, so we have moles, we have liters. We're good. So 25.5 divided by molar mass divided by 0.5. So I got 0.622 when I round. 0.622 molar sodium CH3COO. All right, now let's look at our acid and our base. Are they within the range of 0.1 to 10 of the ratio? Yes. Then we have a buffer system. We can use Henderson-Hasselbalch, and that makes life so much easier. Or you can just make an ice table if you really want to make an ice table. By all means, do it. All right, so here we know that pH, pKa plus log base over acid. All right, it gives us the Ka. If you have not figured out that the pKa of acetic acid is 4.74, you haven't worked enough of these problems yet, plus the log of the base. Remember, work in the problem. Identify your acid and your base first. So base here, 0.622, 0.550. So 4.74 plus log 0.622 divided by, I already forgot, 0.550. 4.79. All right, so that's our initial system. All right, which makes sense because we have slightly more base, so it should be more basic. Now, here we get into, just like what we did with the titration, you have to do your stoichiometry calculation first, where we're in millimoles, and then we can do our equilibrium. So stoichiometry first. This is a two-part or two-step process. So now this is OH. Which component of the buffer system is the hydroxide going to react with, the acid or the base? We should know at this point that hydroxide is going to interact or react with the acid. So here we have OH minus plus the acid. It's going to take this hydrogen off, and that's going to leave us with water and conjugate base. All right, very good. Now let's figure out, we don't have to do mole, we only have to do moles of one of these, because it tells us we have 0.015 moles of hydroxide. So let's figure out how many moles of acetic acid. So when we need to find moles, let's just start with 0.550 moles. I'm going to say AA for acetic acid per 1,000 milliliters. Now, because I just broke down molarity into moles per liter. I haven't done anything yet. Now, look back in the problem. The final volume of the solution is 500 milliliters. So that's how much we have. So when we're dealing with rather high concentrations and high volumes, we don't have to go to millimoles, so that helps. All right. So 0.55 times 500 divided by 1,000, 0.275. So 0.275. Now, we know that all of this base is going to react with the acid, minus 0.015, and the acid that reacts, so we can say 0.015 if that helps you out. So it's gone away. And what happens to this acid? It becomes conjugate base. So there's the moles. It says no change in volume, so that helps us out a lot. So let's subtract 0.62. And how much? Oh, I didn't do this one yet. We got to figure out how much of this is initially in our buffer system. I was like, no, I missed something. All right, so because we have, this is our before addition, then we add, and we figured out our after. This is a buffer system, so we have some of this already in the system. How much do we have? We're going to do the same thing, 0.622 moles per liter, 0.5 liters. I'm just not doing the milliliter conversion. 0.622 times 0.5. So 0.311 plus 0.015. No, that didn't work. 0.311 plus 0.015. There we go. 0.326. This is moles. This is moles. We have no change in volume, so we still have 0.5 liters. 0.5 liters. If you want to go to molarity, since the volume is the same, you can do this calculation, or you don't have to, because all you need is the ratio for base and acid. So when I worked this problem, I didn't go back to molarity because I was tired of writing. So I just said pH, pKa plus log base over acid, pH, pKa of acetic acid 4.74, base here 0.326 over 0.260. Or you can convert them to molarities, but again, this is a ratio, so the units are going to cancel. So they either both need to be in moles or they both need to be in molarity. As long as they're the same, you can do the ratio. 0.326, 0.260. Let's take the log of that, add it to 4.74. 0.4, not 0 4.84. Which makes sense. It should go up a little bit because we added base. Now, part C, which is over on the next page. What happens when we add HCl? Well, HCl is an acid, so it is going to react with the base component of the buffer system. So we'll put H plus for our acid. It's going to react with our CH3COO. If you want to put sodium in there, that's fine. You don't really need it, to make the acid. Now, the good news is we've already done most of these calculations, so this will go a lot faster. So here we don't have any. Our base that we started out with was 0.311. And our acid was 0.275. All right, and we just added 0.025. That's going to get used up. 0.025, because it's going to all react with the base. So over here it's going to get added. 0.25. So that's going to go away. Subtracting 0.311, not divided, minus 0.286. And here, that's moles. And that's going to be 0.3 moles. If you want to go to molarity, go to molarity. It's not necessary. pH, pKa 4.74, plus the log base. Here's the base, 0.286 over 0.3 divided by 0.3. Let's take the log of that and add it to 4.74. 4.72. Which makes sense. The pH went down because we just added acid.